Welcome back to Programming Logic and Design. We're going to be discussing a bit about creating animation. Now, what is animation? Animation is the rapid sequence of still images, each slightly different from the previous one, that produces the illusion of movement. Now, I want you to think of cartoonists. They create animated films by drawing a sequence of frames or cells. Now, these individual drawings are shown to the audience in a rapid succession to create the sense of a natural movement. Now, you create computer animation using the same techniques. If you display computer images as fast as your CPU can process them, you might not be able to see anything. So most computer animation employs a thread class sleep method to pause for short intervals between animation cells, so the human brain has time to absorb each image's content. Remember, our brain is not as fast as the computer CPU. Many object-oriented languages offer built-in classes that contain methods you might use to draw geometric figures on your screen, such as draw line, draw circle, draw rectangle, and so on. You place figures on the screen based on a graphing coordinate system. Now, please note, this is very different to the graphing coordinates or graphing system that you were used to from math school. Let's have a look. We have our usual, which we know from maths from school. We have horizontal, vertical. Horizontal, this way, is your x-axis, your x-coordinate, and vertical is this way. Still same as the maths plane, your math plane, which you had for graphing your diagrams, like your parabola and your straight lines, etc. Now, your x-axis is the position as well as your vertical, and your y-axis is your position on the screen. Now, let's have a look at figure 12.16 to actually explain this more graphically. We have our x-coordinates, which increases this way to the right. We have our y-coordinates, which increases down, and upper left corner over here of our window is our position 0, 0. From there we build our window, and from there we create our positions 20, 20, 20, 50, 50 correlates to the y coordinates, 80 correlates to our x coordinates, and 50 correlates to our y coordinates. Now, artists often spend a great deal of time creating the exact images they want to use in an animation sequence. Now, as a simple example, figure 12.17 shows the moving circle class. Now, as its name implies, the class moves a circle across the screen, such as the Java program here shows the output of a moving circle application. So what we're actually doing here is we have a class that contains data fields to hold our x and y coordinates that identify the location at which the circle will appear. The constants size and increase define the size of the first circle drawn and the relative increase in size and position of each subsequent circle. First circle, and each circle gets increased. You try to say that faster. So, we have the moving circle class assumes that you are working with a language that provides a draw circle method. Okay, there's our draw circle method, which creates a circle when given parameters for horizontal and vertical positions and our radius, which is our size. Now, assuming you are working with a language that provides a sleep method to accept a pause time in milliseconds, remember we need a sleep, which to pause for short intervals between animation cells. So our little human brains has time to absorb each image's content. Now, we use the sleep time over there, constant, which provides a 100 millisecond gap before the production of each new circle. we want to be able to see the second circle drawn after the first, the third circle drawn after the second. You want to be able to see that, else it's just going to look like it looks at the moment. We will never see it drawn if we did not have the sleep method. So, in most programming object-oriented languages, a method named main, over here, executes automatically when a class object is created. Remember your public static main method, which is in your application class? Same here, this will execute automatically when a class object is created. So the main method in the moving circle class executes a continuous loop. While true, repaint screen, end while. Pretty simple. So the program execution will cease only when the user quits the application by clicking the close button. It's the only way we're going to exit. All right. In the repaint screen method here of the moving circle class, a circle is drawn in the X, Y position. Then the X, Y, and the circle size are increased. So all of them are increased. And what is my increase? Is size divided by 10. My size is 40 divided by 10. And that will be my increase. So it draws a new circle more to the right, further down, and a little larger. More down, more to the right, further down, and a little larger. The effect is a moving circle that leaves a trail of smaller circles behind as it moves diagonally across the screen. Although an object-oriented language might make it easier to draw geometric shapes, you always can substitute a variety of more sophisticated, pre-drawn animated images to achieve the graphic effects you want within your programs. Now, an image is loaded in a separate thread of execution, which allows program execution to continue while the image loads. This is a significant advantage because loading a large image can be actually very time consuming. What I want you guys to do now is many animated images are available on the web for you to use freely. Use your search engine and keywords such as GIF, GIF files, JPEG, JPEG files, and animation to find sources for shareware and freeware files. Thank you for completing Events, Threads, and Animations. Please join me in the next chapter where we will be discussing UML diagrams.